Let's begin. So remember, we're into two-dimensional here. The basic idea remains the same, though, that the initial momentum must be equal, both numerically and directionally, to the final, right? So here we've got two identical curling stones. Their mass 19.5 kilograms. They collide as shown. I guess I need to get a picture. The first stone hits the stationary second stone with a velocity of 5 meters per second north. If the velocity of the first stone is 3.5 meters per second north, 30 west after collision, find the velocity of the second stone after collision. Of course, omit friction. So let's just draw a before and after. Okay? And I'm going to draw them in two different colors just so they're easy to identify here. So let's just say the red one is here at rest. And I'll draw a black one here. And I will say it's moving at 5 meters per second. And when it hits, it's going straight north. So that's the before, and here's the after. So after we've got, so the first stone, the black one goes north 30 west. So after we've got that, and of course the red one's going to go this way. So I guess they don't hit, doesn't hit square on to start, right? And I'm sure even with whether you've got limited or extensive curling experience, you would realize that if the black one were to hit the red one like that, right? Well, then the red one's going to go that way, and the black one's going to go that way, right?
I used to curl when I was a kid, Mr. Man.
Yeah?
I won a Bonusfield.
You want a what?
Bonusfield.
Did you win how to pronounce the word Bonspiel poster or anything?
And after we won, they gave us 4 trophies.
Yeah?
I was on Sonia, Kayla, and Chris.
That's why I won, because they cheated.
And I was the first.
Yeah?
I got lots of points. I was good. I was a good curler. And
Yeah.
at the end,
I want to hear the story.
They made 2 Kayla Johnson trophies. So they screwed it up. So they gave me a Kayla Johnson trophy. I never wanted to play curling again.
So you realize that first.
All right, so how are we going to do this here? I'm going to set it up. I'm going to say initial is equal to final. Now remember, because this is 2 dimensions, we're going to have to deal with directions themselves, right? Yes. Okay. So we could also say that P1 initial, because we're going to call the black one 1, P1 initial is equal to P1 final plus P2 final. And these, my friends, are all vectors, right? This vector here, right, has to equal these two. In fact, if I go like this, right, that would have to be equal. Obviously, I'm not drawn to scale here. I guess if I do this, let's just see if I can do this here. Yes, the arrow should be stretched out,
What
right?
does that stuff mean, the second one?
Like it should be kind of like this, right?
Does that say the PI1?
Yeah, the PI on the first rock equals the PF on the first rock and the PF on the second rock together. It's vectors. Your final vectors are equal to the first vector. Remember, adding vectors, it should always equal up. The first rock and the second rock.
Doesn't want to, yeah, something like that, right? Okay, yeah. I started to scale it and started to funny counting. Okay, so we're going to have to deal with vectors. Now, what we're asked to find is the velocity of the second stone. So that's this one here. So really, what I'm saying is P2F, right? If I'm going to take this to the other side, it's going to be P1 initial minus P1 final, right? Like all I'm doing is taking that guy over to the other side.
This little M
means vectors. So really what we're talking about here is we are talking about our old friend vector subtraction, right? I haven't done any math yet. Well, no, I should clarify. I haven't done any arithmetic yet, but have I done math? I would argue yes. All right. So the final momentum of rock 2 is equal to the initial momentum of rock 1 minus the final momentum of rock 1. Is that correct?
Chips ahoy, push your boy.
Okay, so now let's just straight convert right to components. So P1I P1I looks like P1I is this one here, right? It's the 5 straight up, right? Good. So therefore, P1I X is equal to 0, and P1IY is equal to plus 5. And you might remember me saying at the start, the subscripts in here are crazy. And I don't think anyone would disagree with me that we are into crazy mode. Let's look at PIF. P1F, not PF. P1F is this one here, this 30, right?
So P1I. Oh, change that.
No, oh yeah, F, thanks. P1F is this, right? And it is 3.2 and 30. So P1FX is going to be 3.2. X is up here, it's opposite, so 3.2 sine 30. Oh, hold the fort.
Negative.
Where's my mistake? Anyone? I foolishly skipped a step or two in my, I thought, they don't need to see that.
A step or two. Oh no.
What is 3.2 equal to? Is the
The velocity.
velocity, but I'm talking about P. P is momentum, which is mass times. We didn't multiply by the mass. Am I good oh no, I'm not good here either, am I, right? That P1I is not 5, it's in fact 19.5 times 5. Right? Mass times velocity. I apologize, I did not make that mistake on purpose, but it's a good example of an easy mistake you could make.
Yes, it is.
That's good accidental teaching.
Should be good at that.
You are good at being an accurate teacher.
I don't know, is it good to be good at that, or is it bad to be good at that?
As long as you're good in the end.
Okay. So 19.5, I get 62.4.
What?
When I multiply 19.5, oh no, that's wrong.
I got
97.5, yeah. That mistake, it wasn't
That's a
good.
double wrong.
That was not a good mistake.
Which makes it positive.
Okay, so now this here should be what? Mass times velocity. This should also be 19.5 times 3.2 times the sine of 30. That's your 62.4, right, Mike?
Yeah. It is. 90 subscripts. 1FX.
31.2?
Yes, my God.
Yeah? And it's to the left, so it's going to be negative.
Now we have to do the same thing.
P1FY is 19.5 times 3.2 times the cosine of 30. And I get 54, is that right? 54, but that is
No, you're good.
positive. Okay. Woo! Okay, so vector subtraction, right? Okay, so vector subtraction. P2F is the I minus the F. So IX, okay, so I'm just going to write right underneath here, P2FX is 0 minus minus 31.2, which of course gives you 31.2, which makes sense. The x-coordinate of the other guy is to the right, correct? The red one. And P2Fy is going to be 97.5 minus 54.
There's actually a curling question. Oh yeah, it is.
Yeah.
I thought, yeah.
And I get 43.5. And that's positive.
Oh, you make
Where
guy.
did the zero come
I mean,
Get,
there's no x component of this, right?
Oh, yeah.
I mean, really, you could argue this is simply application of vector subtraction, couldn't you?
Essentially.
Right? I mean, it's essentially that, isn't it?
A little bit more in discussion.
Yeah, the theory ahead, right? But okay, now what do I do with my vector subtraction?
Draw a diagram.
Draw a diagram and combine them, exactly.
Your result is
31.2, 43.5. This is P2F. P2F squared is equal to 43.5 squared plus 31.2 squared. You guys can do the Pythagoras, I'm pretty sure. I get 53.5 kilogram meters per second. But the question was, what was the velocity of the second stone, right? So now I have to do what? Am I ready for the angle yet? I'm asked to find the velocity.
What do you like to divide by the weight?
Got to divide by the mass, exactly. Right? P equals mv. 53.5 is 19.5 v. You get a velocity of 2.7 meters per second, which seems about right because the rock's coming in at 5, right? And one's leaving at 3.2, so the other one's going to be around that. Yeah, about 2.5, that makes sense. 2.7. And as Mike pointed out, angle. I get like 54, I think, right? Can someone do that? I did it backwards on my sheet. Is it 54? Ish? Yeah. Okay. So that's going to be west 54 north. Whew. How many marks?
47 point.
Well, one there, one for that.
What's 54 now? Why?
Just the way I drew it here, right?
It's definitely not going.
Oh, east. If I say it one more time, I'll be right. Yeah. Sound like my dad there. That's scary.
2, 3.
1, 2, 3. What do you think? One each here or just half each there? Half, yeah. 4. 5 for those, 6 for those. Probably 6 altogether.
Maybe 6.5.
I'm not giving a half.
Just go.
A 5-kilogram bomb at rest explodes into 3 pieces, each of which travels parallel to the ground. In other words, it's 2-dimensional, not 3. That makes it hard. The first piece with a mass of 1.2 travels at 5.5 meters per second at an angle of 20 south of east. The second piece has a mass of 2.5, travels at 4.1 at an angle of 25. Determine the velocity of the third piece.
I know what your hint's going to be.
What's the hint going to be?
Px equals 0.
Oh, excellent. I'll start, and then we'll see how you guys do. I'll start. No, my hint was, what's the mass of the third piece?
It's 5. I mean, no. It's not 5. It's a piece.
It's 1.3, Mike.
5 minus 1.2 minus 2.5, isn't it? Now, in teacher talk, that's the giveaway mark. That's the half mark that everyone gets, Sean. Make sure you get that mark.
Get that mark, guys.
Because the bomb is at rest, the PI is equal to 0, which is equal to the final, right? So really, I don't even really need to say PI equals PF. I just set PF equal to 0 and go from there.
Why is P a 0?
Because the initial is 0. Right? In other words, all of these pieces, the first one goes at 20 south of east, right? So that's going to be south of east. It's going to be like this. And the second one is 25 north of east. So the third one's going to have to be something like that, right? Oh no, that's wrong, isn't it? What's wrong with that? Should be, yeah, not the result, right? Yeah, equilibrium. It's really an application of that equilibrium stuff. You could also say that this also means that the sum of x components is equal to 0, and 0 is equal to the sum of the y components. Right? Like the x component at the end has to be 0, and the y component at the end has to be 0. Right? If either one is any other number, then the overall final momentum is not 0. So I'm going to write this. I'm going to write 0 equals P1x plus P2x plus P3x. I'm not going to worry about prime. I'm not going to worry about finals because we're just talking, everything's final, right? Everything's after explosion. Because it's equal to 0, we can get away with that. And I'm going to also write 0 is equal to P1y plus P2y plus P3y. So it's a matter of finding the components and doing the subtraction. I apologize if you've already written this down. Okay, so what are we solving for? I'm solving for P3x, right? So P3x is going to be equal to 0 minus P1x minus
Are we supposed to do this one on our own?
Oh yeah. Have I given you enough hint, do you think?
That's a lot of things.
Hey, man.
All right, let's just do it.
No.
No?
No.
Okay. All right, let's have a look. So, P1x, let's see here. Maybe we should draw a picture here, right?
I tried to draw the Q&X, but I didn't.
Yeah. Let's draw P1 is,
South of east.
right, so that's like this, right?
Yes.
Okay, so this is P1, this one is P1y, and this one is P1x. And the value is
I know which way it flies.
Use 6.6 if you want.
1.2 times
5.5.
5.5.
6.6.
6.6, right. Okay. So P1x is equal to, it's adjacent to the 20. So that's going to be 6.6 cos 20, which is, I don't have an answer.
Look at that first piece.
I need a calculator. Sorry for that. 2.5 times 4.1 is 10.25. And the x is going to be adjacent, so that's going to be cosine 25. $9.29. And that is to the right, so it's positive. And P2y is going to be 10.25 sine of 25. Or 4.33, and that is positive. Okay. Do you see how all that stuff that I talked about in grade 11, how organizing your work, how important that is now?
You never said that.
No, never.
Yeah, whatever. I never said show your work.
So,
Okay, so P3x is negative P1x, so minus 6.2 minus 9.29.
so that is the forces that you have right now. That's
And P3y is minus 2.26 subtract 4.33
why is it negative like that?
because it's up here, right? P3x is 0 minus P1x minus P2x, and P3y is negative
How do you know that formula?
because way back up here, remember I said that the initial is equal to 0, which means the final has to be equal to 0. So if the final is 0, the sum of all the x is equal to 0, and the sum of all the y is equal to 0. So in other words, 0 equals P1x plus P2x plus P3x. P3x, then take these to the other side, and it's 0 minus that, right? So P3y is the same thing. It's minus P2y minus P1y, right? So you have to have negative to their value. So it's negative minus 2.26. So that's going to be 2.26 subtract 4.33, and I get minus 2.07.
Now we draw another diagram.
Correct, Mike? So negative x is to the right. Negative y is minus 2.07 is down like this, right? P3 squared is equal to 15.5 squared plus 2.07 squared. P3 is equal to 15.6 kilogram meters per second. Okay, terminal velocity of the third piece. So again, P equals m times v, 15.6. The mass of the third piece we found out way at the top was 1.3, giving us a velocity of 12. And of course we need an angle. Opposite over adjacent, so 2.07 divided by 15.5. And I get west 8 degrees south. Pretty big question, isn't it?
You get 7.6 in this round.
Yeah. Okay, so there are some book questions if you want on page 301, numbers 1 to 4, 312, 85 to 94, and I've got, I don't know what this means, but it says read page 302. All right, so the rest of the plan is then for the rest of the week, I'll give you, because you're not going to have enough time today to do too many questions, I'll give you tomorrow to work on some 2D problems, because you're going to need that time. Wednesday we'll do the two-dimensional lab. Hopefully we can complete that in one day. Thursday will be sort of a wrap-up kind of last questions type of thing, and then we'll have the momentum test on Friday. Because we can't have it the next week, because that's right before a long weekend. You can't have a test on before a main long weekend. It's not right.